So in class over the last few days, I have had you working with the key features from the various ways that we can write quadratic equations. And so what I want to do is create this little summary video and talk through and just make sure that everything that you should have picked up from the various Desmos activities or your practice really gets hit home. So what I'm going to talk about is the standard form, vertex form, and factor form. I am going to give you the general form of the equation for each one, and I'm going to list out the key features. So for standard form, we've got f of x is equal to ax squared plus bx plus c. And we're talking about two key features that we should be able to just look at the equation and know. Based off of your a value, you should be able to tell me concavity. So the a value leads us to know our concavity, and I'm spelling that wrong, so let me try that again, concavity for the graph. Okay, let's again try that again. So graph. All right, if a is positive, I'm having issues writing today. Okay, let's try that again. If a is positive, the graph is concave up. If a is negative, the graph is concave down. And that's the a value information, okay? Now, in terms of the other piece of information that this equation can give us, it's based off of your c value. All right, the c value is going to tell us the y-intercept. And so for the y-intercept, you can write the point 0, c. So whatever this number is at the end, if it's positive 5, awesome. If it's negative 57,000, that works too. Both of those, whatever it would be the y-intercept. Okay? So those are the key features from standard form. Let's talk vertex form. So vertex form is f of x is equal to a times x minus h squared plus k. One thing that hopefully you noticed right away, maybe you did, maybe you didn't, this a value is the same a value that was in standard form. So if that's the case, the a value is still going to tell us the concavity. And so we don't have to worry about it. It didn't change, right? A is positive, concave up. A is negative, concave down. Same information. This one also tells us some other information. So mathematicians, not creative. This h value right here and this k value right here are the vertex of your parabola. So hk is the vertex. Now, one quick note, please note that this is x minus h, but when I wrote down the actual vertex point here, I just wrote down the positive h. So, just for awareness, okay, this is going to be the opposite. And so if this says x plus 3, I would use the opposite value here and say it's negative 3. If this is x minus 2, I'm going to do the opposite, which is just positive 2. One other piece of information that you can get from vertex form, and technically it comes right from the vertex, is what's called your axis of symmetry. Axis of symmetry is going to be the vertical line. X is equal to whatever h is. All right, so this h value is going to match to this vertex value right here. So that's vertex form. We've got one more to talk about, which is factored form. So f of x is equal to a times x minus r1 times x minus r2. And if we notice, hopefully we do, hey, look, it's a again. So that a value is the same thing we've been talking about, right? That is your concavity. All right, so if we know we've got concavity here, let's see what else we have. And we've got an R1 here, we have an R2 here. Those are your x-intercepts. So when I go to write the ordered pairs, it's R1, I'm going to write that as a 1, comma 0, and R2, comma 0. All right. So again, being careful to pay attention to this said right here, x minus R1, but when I wrote down the value there, I just wrote down R1. And same thing here, where this says x minus R2, this is just R2. Okay? So that's the key features. That's kind of the summary of what's been going on. Just for practice, I'm going to go ahead and do a couple of examples really quickly where we actually have some functions. We're going to identify if it's standard, vertex, or factored form, and then identify those key features that are easy to find. So that's exactly what the directions say. Classify each quadratic function by its form. Form means we're talking standard, vertex, or factored. Then list the key features that are easy to identify. All right, so if I just zoom in on this first one, I need to figure out its form first. This is in vertex form. Okay. If it's in vertex form, you should be able to tell me the concavity. You should be able to tell me the vertex, and you should be able to tell me the axis of symmetry. All right, so first things first, if we're looking at concavity, I want to look at this leading term here, this leading number. It's a negative value, so that tells me that we are concave down. The next thing I'm going to look for is the vertex, so we're going to go with the opposite of what's attached to x, and this just number at the end, the constant. So the vertex here is going to be negative 2, 7. And once we know the vertex, the axis of symmetry is x is equal to negative 2. So that's that first one. Let's go ahead and slide on over to the next one. So f of x is equal to negative 2/3 times the quantity x minus 3 times the quantity x plus 12. Form, this is factored form. All right, so this is factored form. If it's in factored form, you should be able to tell me concavity, and you should be able to tell me 2 x-intercepts. Okay, so let's get concavity first. This leading value is what's going to tell us the concavity. That's your A value. And in this particular problem, our A value is negative, so this is concave down. Let me actually try and write that without weird letters in the middle there. There we go, concave down. And then we want to pick up our x-intercepts. So it's the opposite of what's attached to x in both cases, and make sure you write them as ordered pairs. So x minus 3 gives us the x-intercept of 3, 0. X plus 12 gives us the x-intercept of negative 12, 0. So that's all the key features for that one. I'm going to go ahead and slide down to the third one here. F of x is equal to 7x squared minus 15x plus 3. This is standard form. So standard form is the one we've probably been working with the longest because it's the one we use for quadratic formula. It's the one we use for factoring. It's got a lot of uses for it. But if it's in standard form, we're going to talk about the concavity, and we're going to talk about the Y-intercept. Those are the key features that are easy to find. So concavity, leading value here, your A value is positive 7. So this is concave up. Your C value is positive 3. So that means my Y-intercept is 0, 3. Please make sure that your intercepts are being written as ordered pairs so that you make sure that you are getting the right notation. Okay. Last one here, we've got f of x is equal to 4x squared minus 3x. It looks a little weird, but this is standard form. All right. The reason it looks a little weird is because it's missing the c value here. So to fill that in, you could simply just put plus 0. All right, that would give us then the full standard form that we're used to. So if we're talking standard form, we're talking about concavity, and we are talking about the Y-intercept. Okay, so starting with concavity, it's a +4 to start, so this is going to be concave up. And if we look at our C value here, remember it didn't exist, but adding 0 doesn't change anything, so you can go ahead and add 0. That gives us a Y-intercept of 0, 0. Okay? So that's the kind of summary of what we've been doing the last few days. I hope this clarifies any questions that you might have still had. If you do still have any questions, feel free to send me an email and let me know what you need some help with.